Welcome to this session where we're going to do matrices, and our main focus will be solving the systems of equation which are in three variables by using Cramer'S rule. So let's get started. So we've been given these equations. So the first thing we need to do is to convert these equations in matrix form. So how do you get to do that? So this is what you do. Okay, so you just take the coefficients. So the coefficient for the first column. So the first column will have only coefficient of x, and we are going to have 1, 3, and 2. The second column will have the coefficient of y, so that is 2, 1, and 5. And the third column will have the coefficient of z, and that is -1, -2, and also 1. Then we'll distribute these x, y, z in this column. Then we'll have is equal to, we have 3, 6, and 13. Like that. So the first thing we need to do here is to find the determinant of this original matrix. Okay, so this is what we get to do. So the matrix is that, so let's find its determinant. So I'm going to say it is 1, 3, 2, 2, 1, 5, -1, -2, and +1, like that. So whenever we are using Cramer'S rule, you need to find first the determinant of the original matrix. So we've made a video, we have a video for determinants of 3x3 matrix. You can check out on our channel so that you get to understand better, but we'll do it again. So how do you find the determinant? So I'm going to say determinant to be equal to, so you say, you take the leading sign, positive, negative, positive. So this will be the positive, negative, and the positive again. Okay, so this is what you get to do. So you need to start with the first number in the first row. In the first row we have 1, so you overshadow this and that, everything in the first row and the first column, because that is where 1 is, so it has to be overshadowed. Then you remain with this matrix. So this is what you get to write: 1, 5, -2, and 1. Then we come to the -2. We come to the first number in the first row, that is -2, because of this negative from the sign table, okay, the leading sign. So if you overshadow this, overshadow the first column, the first row and the middle column, we're going to have 3, 2, and also -2 and 1. Then you say -1. So for this one, we're going to overshadow this, and the first row will have 3, 2, 1, and 5. Then you find the determinant the way you find for 2x2. So determinant will be equal to 1 multiplied by, so the major diagonal is 1, so 1 minus the minor diagonal, that is, this will be what? 5 times -2, that is -10. So because of this negative, it will just be +10 minus 2, then 3 times 1, that is 3, minus, we'll have 2 multiplied by -2, that is just -4, so +4 just, then -1, Then here we'll have 15. 15 minus what? 15 minus, that is 2. So determinant for the original matrix will be equal to, this is 1 plus 10, that is 11. So we'll have 11 minus, because 11 times 1 is still 11. So this is 3 plus 4, 7. 7 times negative 2, that will be negative 14. Then minus 15 minus 2, that is 13. 13 plus 13 times negative 1, that is just negative 13. So this will give us the determinant to be 11 minus 14, that is just negative what? That would be negative 3. Negative 3 minus 13, that will give us negative 16. So this would be the determinant for the original matrix. To get the determinant of x, substitute where in the first row for x, this is for x, that is for y, and that is for z. So x, y, and z. So substitute here where there is x, substitute these values. So what we are going to have is this. So I'm going to say we'll have a matrix 3, 6, 13, then 2, 1, 5, then negative 1, negative 2, and 1. Then we find the determinant of x. Determinant of x will do the same. We'll start with 3. You form a matrix, so you overshadow this and that. Then you get the matrix that remains, which is that part. So have 1, 5, negative 2, 1. Then again, so it will be minus 2 because of the digit matrix, plus, minus, plus. So minus 2, you overshadow this and that. So you get 6, 13, negative 2, 1. Then minus 1 again, you have 6, 1, 5, 13. Then you can find the determinant. So determinant of x will be equal to 3 multiplied by, that is 1. 1 times 1 is 1. 1 minus negative 10. So same as 1 plus 10, that is 11. Then minus 2. So this is 6. 6 times 1, that is 6. Then 6 minus, that is 13 times negative 2, that is negative 26. So 6 plus 26 in short. That should give a what? A 32. Then we have minus 1. This is 6 times 5, that is a 30. 30 minus 13 times 1, that is 13. 30 minus 13, that should give a 17. So determinant of x will be equal to, we'll have 3 times 11, that is 33, minus 2 times 32, that is 64, then minus 17. And what value will we get? So if we say 33, then minus 64. So 64 minus 33, the value we'll get is negative 31. So negative 31 minus 17. What value are we going to get? Okay, so we'll get negative 48. So that will be the value for determinant of x. Then let's move on to determinant of y. So to find the determinant of y, we substitute y there. we substitute these values, right? Okay, so what we're going to have now will be equal to this. So we're going to have 1, 1, 3, 2. Then we'll have 3, 6, 13. Then we'll have -1, -2, and 1. So let's find the determinant. So determinant of y will be equal to, we'll start with 1, we form a matrix, so it will be 6, 13, the way we are doing, 6, 13, -2, 1, then we come to -3, because the leading sign is plus, minus, plus, okay? So it will be plus there, minus there, plus. So it will be -3, we overshadow that, and where -3 is. Okay, so it will be 3, 2, -2 and 1. Then we come to -1, we'll have 3, 6, 2, and 13. Then you can find the determinant for y. So determinant for y will be equal to 1. So it's major diagonal minus minor diagonal. So 6 multiplied by 1, that is 6. 6 minus 13 multiplied by -2, that is -26. So same as 6 plus 26, which is 32. Then -3. And at this point, we're going to say 3 times 1, that is 3. 3 minus 2 times -2, that is +4. That is 3 plus 4, that is just a 7. Then -1. Here we're going to have 13 multiplied by 3, that is a 39. 39 minus 2 times 6, that is a 12. So 39 minus 12, what would be the value? So 39 minus 12. 39 minus 12, we'll get 7 there and 2 there. That is a 27. So we'll have 27. Okay, so determinant of y will be equal to 1 times 32, that is a 32, minus 3 times 7, that is a 21, then minus 27. So this will be equal to what? So we need just to calculate what is 32 minus 21. So that is 1, 3, 1. So it is 11. Then we say 11 minus 27. 11 minus 27 will get 16, which is -16. So we'll get -16. That will be the determinant of y. Let's find the determinant of z. To find the determinant of z, we need to substitute now the z column. We need to substitute these values. So how are we going to do that? Okay. So this is what we are going to do. We are going to have 1, 3, 2, then 3, 6, 13. Then we have we need to substitute z, not y. Okay, so here we have 2, 1, 5, then 3, 6, 13. Then we say determinant of z will be equal to, just the way we are doing it. So it will be plus 1, we form a matrix. So the matrix will be 1, 5, 6, 3. Then there that was plus, minus, plus. So -2. We form another matrix. The matrix we're going to have, it is 3, 2, 6, 13. Then we say plus 3. The matrix we're going to have is 3, 1, 2, 5. So plus 3 is this 3. Then we overshadow the column and the row where 3 is. So we get that this is the one we have there. So this is what to do. Then we find the determinant of z. So to find the determinant of z, we're just going to say 1 multiplied by, so 1 times 3, the major diagonal is 1 times 3 minus, so 1 times 3 is 3, 3 minus 5 times 6, that is a 30, then minus 2, 3 times 13, that is a 39, minus 2 times 6, that is a 12, then plus 3, that is 3 times 5, that is a 15, 15 minus 2 times 1, that is a 2. So determinant of z will be equal to 1 multiplied by, that is 3 minus 30, that is 27, which is negative 27. So 1 times negative 27, that is negative 27. Then here we're going to have 39 minus 12. 39 minus 12, that is 7, 2, 27. So 27 multiplied by negative 2. And that will give us negative 54. Then we say plus, that is 15 minus 2, that is 13. 13 multiplied by 3, that is a 39. Then we get to find what is negative 27 minus 54. So this will give us, so it's 1 there. So it will give us 81, negative 81. So negative 81 minus 39. So 7 there, 11 minus, that is a 2. That is a 4. Okay. So 81 minus 39, what is the value? Okay, 81 minus 11. So yeah. So that is 11 to 7 minus that 4. Okay, let's do it here to see the value which we're going to get. Okay. So we are saying 54 minus negative 54 minus negative 27, so 54, we just add them. 54 plus 27, 54 plus 27, this is, let me use a different ink. So we have 54 plus 27, that will give us what? That will be 11, 1, carry 1, 7, 8, 1. So that will be negative 81. So negative 81 now, we say plus 30, plus 39, which is as good as saying, okay, which is as good as saying, what is 81 minus 39, then we put the sign. Okay. So this will give us what? This will give us 11 there, so this will be 7, 11 there, 11 minus 9, that will give us a 2. Okay, then 7 minus 3, that will give us a 4. Let's just check in case we had missed something. Okay, so we said 1, then 1 times 2, that is a 3. 3 minus 5 times 6, that is a 30. That is what we have there. We come to negative 2. Okay, so negative 2 multiplied by the matrix. Okay, so we're considering Z, or Z rather. So the matrix, we had negative 1. Okay, I think we had missed something on Z. Let's just redo it, reform the matrices to see. So for Z, let's check for Z we said we substitute that where there is Z. Then we form the matrices. Okay. So Z, okay, the matrix will be 1, 3, 2, 2, 1 and 5, then 3, 6 and 13. Then we get the determinant for Z will be equal to, okay, so it will be 1 multiplied by, so 1 multiplied by this matrix, which is 1, 5, 6 and 13. Then it will be minus 2 multiplied by this, that is 3, 2, 6, 13. Then plus 3 multiplied by this matrix, which is 3, 1, 2, 5. Okay. Let's now get the determinant. So determinant for Z will be equal to, that is 1. This is 1 times 13, that is 13. So 13 minus 5 times 6, that is a what? That is a 30. Then minus 2, 3 times 13, that is a 39. 39 minus 2 times 6, that is a 12. Then plus 3, we have 3 times 5, that is a 15. 15 minus 2 times 1, that is a 2. So we have a 2 there. So determinant for Z will be equal to 1, 13 minus 30. That should give a what? That should give a 17, right? Then minus 2, 39 minus 12. So that will give us 7, 27, right? Then plus 3, 13 minus 15 minus 2, that is a 13. Let me just punch this to see the value to give us. So we are saying 17 minus 2 multiplied by 27 plus 3 multiplied by 13. Let's see. So this should be negative, sorry, because 13 minus 30 is negative 17. So negative 17 multiplied by 2 times 27, that is 54. So just say negative 17 minus 2 multiplied by 27, then plus 3 multiplied by 13. So the value which it's giving is negative 32. Okay, so we now know that the determinant for z is equal to negative 32. Then to find the values now, to find the values of x, y, and z, what we do, we say x is equal to determinant of x divided by the determinant of the original matrix. Y is equal to determinant of y divided by the determinant of the original matrix. Z is equal to determinant of z divided by the determinant of the original matrix. So this will give the values of x, y, and z. So the first one, determinant of x, we found negative 48. So I'm going to say negative 48 divided by the determinant of the original matrix, we found negative 16. So divided by negative 16, negative 48 divided by 16, negative 16, negative 48 divided by negative 16, that will give us a 3. So this is the value of x. Okay? Then for the value of y, we say determinant of y divided by the original determinant, the determinant of the original matrix. The value of y we found it to be, the determinant was negative 16. So I'm going to say negative 16 divided by the determinant of the original matrix was negative 16, and this will give us positive 1. To find the value of z, we say determinant of z divided by the original determinant of the original matrix, and that will give us determinant of z. We found it to be negative 32. So it will be negative 32. Okay. So negative 32 divided by negative 16, and that will give us a positive 2. So we can now conclude to say, therefore, x is equal to 2, y is equal to 1, and z is equal to, x is equal to 3 rather, y is equal to 1, and z is equal to 2. So these are the values. This is how you get to solve the equation by using Cramer'S method of 3 by 3 matrix. Thank you for watching.